Well, hello again. We are going to be talking about multiplying two-digit number by a two-digit number using partial products versus algorithm. So what does that even mean, partial products and algorithm? So, partial products is what we've been looking at. An algorithm is the traditional way, and hopefully you know that by now. But we're going to look at these two numbers here, 65 times 95 and then the 65 times 95, but using partial products to solve this one in algorithm. And so you can see the similarities in how partial products is very similar to algorithm. It's just broken down a little bit more. So let's go ahead and write them down. So we're going to write 65 times 95. Again, it doesn't really matter which one is on top, but I think 95, those multiples are easier to multiply by than, say, 6 and 5. I mean, I know my 9 is better than my 6's, although, you know, it depends on you, whatever you're going to multiply. But for today, we're going to put 65 on top and 95 on the bottom. So for this instance, I put 65 on top, and I just wrote out both of them. Now I left a little bit more room because remember, in algorithm, if you remember when we're doing 3-digit, 2-digit, and 4-digit by 1 digit, we do more on top. So let's see what it looks like this. Next, you know what? I'm going to go ahead and write all my multiples for 9 and 5. Well, not all of them, but you kind of get the idea. All the first 10. All right. So now once I do this, do I have to do it again over here? No, because they're already done right here. So that'll defeat the purpose. All right. So how are we going to set this up? Remember, on partial product, we're going to have several different steps. So let's go ahead and write our partial equations to the side. First, we have the value of these two. Remember, in partial products, we're doing values. So 5 times 5. So I'm going to write that out. 5 times 5. Then we have the values of these two. This one has a value of 5 since it's in the ones place. And the 6 has a value of 60 since it's in the tens place. So I'll just put 60 there. Now let's do the values of this 9 and this 5. All right, the 9 is in the tens place, so it has a value of 90. You're so smart. 90. And then the value of these two, the 9 is in the tens place again, so 9, sorry, I forgot this one, 5. The 5 is in the ones place. My apologies. Now again, the 90, because it's in the tens place, and then that 6, again, is in the tens place, so it's going to have a value of 60. Sometimes I get ahead of myself. Apologize about that. So now all we have to do is add or multiply these partial equations. So 5 times 5 is 1, 2, 3, 4, 5, 25. Hopefully you know those 5s though, so you really won't. Now I'm making sure I line up my ones places and my tens places. How many zeros in our factors? We have 1 0, so 1 0 in our product. At least 1 0 actually. 5 times 6, 1, 2, 3, 4, 5, 6, 30. So it ends up being 2, but one of those comes from the extra 0 in the factors. All right. 90 times 5, how many zeros in our factors? 1. So we're going to have to at least 1 0 in our partial product here. 9 times 5. I can go to these 1, 2, 3, 4, 5, or since this is 5s, 1, 2, 3, 4, 5, 6, 7, 8, 9. Ends up being the same thing, 45. So 90 times 5 is 450. All right, and then 90 plus 90 times 60. How many zeros? We have 2 zeros. So we're going to have at least 2 zeros in our partial product here. 9 times 6, 1, 2, 3, 4, 5, 6, 54. So it ends up 90 times 60 is 5,400. Now we're going to add them up. 5 plus 0 plus 0 plus 0 is 5. 2 plus 0 plus 5 plus 0 is going to be 7. No regrouping necessary as there's nothing to carry over so far. All right, 3 plus 4 is going to be 7. 7 plus 4 is 11. So we have 11 hundredths. So then one of those hundreds becomes 1,000. Because there's 11 hundredths. All right, and 10 hundredths make 1,000. 1 plus 5 is going to be 6. Add the comma, and no, this is not a bad, this is just a bad one. So 6,175. Now we're going to do the same thing, multiplying with algorithm here. But for this, we're multiplying the digits instead of the place value. So they're already going to stay in the same place value. So basically what you're going to see is that these two are going to be put together, and then these two are going to be put together. Everything multiplied by the 5s is going to put right in the first line, and everything multiplied by the 9 is going to put in the second line. So if we were to add these two, so the first one should be 325. Let's see if that works. 5 times 5 is 1, 2, 3, 4, 5, 25. Now instead of writing 25 both down here, we're going to start doing some of the adding already. So we're going to say plus 2. Now I'm putting plus 2 again, remember, because we are adding the 2. We're not going to multiply by it, we're going to add it to the partial product we have right here. So 5 times 6, 1, 2, 3, 4, 5, 6, is going to be 30. So we're going to have 30 plus 2. So 30 plus 2 is going to be 32. So now we're just going to put the 2 goes in the tens place. And then, so we have 32 tens. So, and then we could carry the 3, but there's nothing there. So 5 times 0 is 0. 3 plus 3 will be 3. So we're just carrying it. We're just bringing it down. So 325. If we add these together, that would be 325. Right. Now 9 times 65. Let's see if it equals these two added together. So 5,850. So 5,850 is what we should have right here. So all right. Before we start, we need to cross this one out because this one is so last season. Okay, so now this is the tricky part. So since this 9 is in the tens place, and we would generally, so this becomes 90 times 65. Okay, so 90 times 65, so we're going to pretend this is a 0 here. 90 times 65. What do we have to do? If we have a 0 in one of our factors, we have to bring a 0 down. So since we have a 0 here, we're going to bring down the 0. We're kind of like laying an egg. Alright, so then we have our 0. So now we don't have to worry about that anymore. We put the 0 there, and now we can multiply. So just like we would put a 0 here when we multiply by 90, since now it's 65 times 90, we're going to put a 0. We have 1 0 in our factors, 1 0 goes in our products. So now we can multiply by the values. 9 times 5, 1, 2, 3, 4, 5, 45. I'm going to bring that 5 down. And this is where it gets a little tricky with algorithm because it's no longer in the ones place, it's in the tens place. But you think about it, this 9 is in the tens place, so that's where we're going to start. Okay, and so we had 45. 9 times 5 was 45. So what do we do with the 4? That's right, we carry it. We're going to regroup, put it plus 4. So we have 4 tens. So we're going to add those 4 tens. 9 times 6. 1, 2, 3, 4, 5, 6. 54. So now we have 54 plus 4 is going to be 58. 8 goes in the hundreds place. And then again, we could put the 5 over the hundreds place, but there's nothing there, so it'll be just bring down the 5. All right, so do we get 5,850? Yes. So even with algorithm, we get some partial products here that we have to add together. But notice that when we do partial product, we kind of do every value of every digit, and then we add all of them up. With algorithm, we're doing 5 multiplied by everything on top, and then 90 multiplied by everything on top. All right, so that's kind of how it works. So now we have to add. We have 5, 7, 11. Okay, the 1 to the thousands place because we have 11 hundreds. 6. So 6,175. So no matter how we did it, we ended up with the same thing. We're going to do this now, but you notice algorithm actually takes less space. I think partial product's easier to see because you break it down a lot more, but algorithm does take up more space. So you're going to get to decide which one you want to use in class right as of this point, but you need to know how to do both of them. That is the key, is knowing how to do both of them. All right, so we're going to start the next two by yourselves. Alright, so I'm going to go ahead and put 98 on top and then 76. And I want you to set it up like this. Now you are going to solve it by yourself. I've already taken up a lot of time, so I want you to solve these two on your own. That is your goal, is to solve these two, and then I will show if you are correct. But the first thing we're going to do is write our multiples to the side here. Alright, so I went ahead and wrote my multiples to the side. You're going to do the same thing. So first thing I want you to do is pause. I want you to solve this one by yourself and then try to solve algorithm by yourself. So think about the values and then go ahead and solve it. Did you pause the video yet? If you haven't paused the video, pause it before you do this, okay? Alright, for partial product, I ended up doing 6 times 8, 6 times 90, 70 times 8, and 70 times 90, and then had these partial products here. I added them up to get 7,448. If you didn't get that, pause it, and I want you to go back over and see where you messed up. See how yours is different than mine. After you finish that, let's pause, and you're going to go ahead and solve this one. Alright, so before I move on any further, I did 6 times 8 is 48. I put the 8 in the ones place. The 4 goes over the tens place, and remember, I put a plus sign because we're going to add it. 6 times 9 is 54, so we had 54. Plus 4 was 58, so there we go. Now I'm going to cross these out because they're so last season. And then we're going to multiply by the 7, which is not just a 7, it is also a 70. So when we multiply 70 times 98, how many zeros in our factor? We have 1 0. So it's going to be 1 0 in our partial product right here. 1 0. Then we go ahead and multiply. 7 times 8 is going to be 56. Put a 6 in the tens place. Make sure I line them up correctly. Plus 5. And I crossed it out, and this goes over the tens place. But we cross that other one out so we don't mix it up. 7 times 9 is 63. So it's 63. Plus 5 is 68. And then all we have to do is add them. We get 8. That's horrible. 8. 14. 14. And then 7. So 7,448. So again, it doesn't matter which way we do it, we get the same product. Now what I want you to do is on the left side, you're going to solve a simple one. Let me make it pretty simple. You're going to multiply 25 times 12, and I want you to use partial product and algorithm, and I'm going to show the both, and then we're going to share them in class. Alright, so 25 times 12. That's it. Have fun being a mathematician.